designed with communications being the forefront of its main usage. Basically getting information from point A to point B, whether that be on a LAN, a WAN, or using more recent technologies, a wireless network. Very similar to operations of the telephone network. Over the years since it has matured though, we've seen a gradual trend in which it's been changing from being predominantly communication-based to more content delivery-based. This can be seen in a multitude of different ways as users, actual usage of the internet, but more commonly it's seen through the bandwidth usage of users on the internet, in which you can see that predominantly now people are using the internet to deliver and stream videos and download videos. So content delivery is broken up into two major categories. One is content distribution networks, and the other is peer-to-peer networks. Now, you probably have experience with both of these. The common method you see corporations using is the content distribution networks. You see this on sites such as YouTube, where there is a server room somewhere that is based on your geographical location. It sends out requests and paints that the geographically closest server to you and pulls the request for the information and streams the video. Peer-to-peer works differently. Basically, it queries everyone on the network that holds that media and requests that media to be streamed to your set computer. Then all those computers that hold that media decide to chip in and pull their resources together to get the service that requests. Server farms. No matter how much bandwidth an individual machine can handle, you're going to run into problems with serving requests, because any machine can only serve so many people. The simple solution to that is to get multiple machines. This leads to the model of server farms. As you can see here in this figure, this is a simplistic server farm. You see the client queries the server here. The front end then distributes the workload to all these back-end servers, which then corresponds to the actual database to pull information and service requests to the client. So server farms are obviously clusters of computers or machines that act as a single server entity as far as their operation. Now, the difficulty that comes with server farm implementation is the fact to a client it has to appear as I'm interacting with one entity. So this is most commonly addressed with DNS, which essentially what they do is create a DNS, generally a URL for, let's say, YouTube. And as you're addressing YouTube, you would put that in to go to the website. But in actuality, YouTube is a list of various IPs referring to geographical locations and servers that they support, to which they use to rotate through. That way, one server doesn't get bogged down. Here's an example of Google's server farm here. That would be one node on a CDN network. Yeah, it is. I wouldn't want to pay the electric bill. And here we get a closer view. You can see each one of these server blades.
Each one's a computer?
Yeah, each one would be a machine on that network. Each one would have a valid IP that would serve for that rotating list when you refer to the DNS.
That's be really fun, man.
Yeah. So, caching. Caching improves the overall performance by shortening the response time and reducing the network load. The best the browser can do for its caching method is actually store a cache on the local drive of whichever machine you're accessing the website for. This works, but one method to increase the functionality of it is to actually make it so everyone on the network can access that same cache. A page is fetched for one user to be returned for another user, so that's improving the efficiency of your being able to correspond with data from that site. Without their browser caching method, this would cause every user that wants to get data from that website to have to physically open a connection to that website and pull down the information. Another method you can increase the speed of caching is using a web proxy. A web proxy is used to share cache among users, and since it is shared across users, it has substantially larger cache than just a conventional browser on an individual computer. When a proxy is used, it's common for an organization to operate one web proxy for all of its users. You typically see this type of setup in a corporate network. I know various places I've interned at that this was a commonplace network configuration that we use. In fact, for my local apartment, we use a software suite called PFSense, which is actually a router configuration that will allow for web proxies and caching to take place on it. It dramatically increases speed and responsiveness of internet. When you use the web proxies, the speeds of web requests reduces bandwidth speeds. Okay. To use a proxy, each browser is configured to address that proxy with any request. If the proxy has already serviced that request, then it's already in the cache for that proxy. So the page will be immediately updated to that individual. If not, then it would stage a request to that website and pull the information down. Then at that time, it would then update the cache of the proxy so that way any following requests would then have that information immediately available. Of course, all this takes place only if the local cache on the individual machine doesn't already have the page cached. A little bit more about CDNs. Although server farms and web proxies are sufficient for the construction of larger websites and performance improvements, they are inadequate for most popular websites. This is largely due to the large amount of traffic that they get. For those websites, CDNs are needed to place a copy of the page in certain nodes at different locations and to direct the client to use a nearby node as a server. Like I said earlier, pretty common sense here. You want the data to be pulled as quickly as possible to reduce latency. So if you live in New York and you're trying to go on YouTube, you don't want to be pulling from the servers that support YouTube in Australia. That's you're going to get very, very bad throughput. Content distributed networks continue. Most companies do not build their CDNs, but instead use the services of CDN provider to make their site perform faster. Entry pages of a website are hosted by a content owner, and the content is hosted by the CDN. Another advantage of using CDN is the episodes of rapid feature demand known as flash crowds can cause websites to crash, and having a CDN gives you a site extra emergency. And what that is basically a lot of people logging into your website simultaneously, DDoS attacks and whatnot. Right, I'm going to hand it over to Bill to talk a little more.
Thank you. So,